Good day, Dr. T here. Unusually, I'm recording during daylight hours, so the window's open. And this is kind of an end of semester reflection. So currently on break, and it's always a good idea to, once you finish something like a semester, to kind of reflect on that semester, what you did well, what you didn't do so hot on, how the next time you're going to do it is going to go. And, well, that's this. So thought I'd do some reflection and just record the reflection. Okay, so for context, this semester I was teaching 5 courses. 2 of them were lecture lab combos. So I was kind of doing a 7-6. Next semester I'm teaching 1 less lab. So, oh boy, overload this year. We've had some staffing issues because, of course, we have. Okay, so I taught 2 survey of chemistry classes. This was the first half of a 2-semester GOB course. Taught an organic 1 lab. I'm going to address this real quick. Okay. Taught an organic 2 lab. Taught a, and then finally I taught a, oh, what was that one? A physical science for teaching majors course, which isn't a lab, but I had a lot of hands-on demos, and we did it in a lab. Not saying it's a lab. It's not a lab, but you might be mistaken if you thought it was. And that was totally on purpose. Okay, so just kind of going through the classes. Actually, let's talk about that last one first. That's where I've made a lot of changes. I think I've got some ideas to go in the future. So I added a lot of demos to this one because this is one of those classes I've never really been happy with. For starters, I'm teaching chemistry, physics, and astronomy. I have an astronomy minor. I really never thought I would use it. I seriously thought spending time watching Scott Manley on YouTube was purely personal entertainment and had no professional development value. I was wrong. I enjoy astronomy, don't get me wrong. So I'm in the chemistry, physics, and astronomy department. I enjoy astronomy, I love it. Physics, I passed it. It's definitely my weakest link. But of course I'm a chemist, so I'm strongest in the chemistry section. So I had done a couple of things. About a year now, I think it was spring of this year, maybe it was fall of last year, I switched the order. So traditionally the textbooks have it, you learn physics, and you learn chemistry, then you learn astronomy, or you learn physics, astronomy, chemistry, something like that. And I said, you know what, I'm a chemist. The way chemists teach, the in thing for chemists, I need to make a video on it, but the in thing for chemists is what's called atoms first. And this has been in thing since as long as I've been around. It messes with your labs, though. I will warn you. If you do atoms first, it will mess with your labs. But the style is you start with atoms, and you learn about atoms, and you learn about electrons, and then you build up from there. Because, that's kind of like how the chemistry works. The valence electrons controls everything. So if you understand the valence electrons, you have a leg up on like everything else. Why do these form covalent bonds? Because that's the way their valence electrons behave. So I was like, you know what? Why don't I do basically that? I will start with atoms, and light and small stuff. And of course, light's kind of hard to just start with light. You kind of have to start with atoms and go down to light. But I'm going to start with atoms and then basically work my way up to galaxies. Kind of never got to galaxies. We had some issues. Had a pipe burst. Well, it didn't really burst. They just forgot to solder the pipe, and it just plunk. So that canceled one class. Yeah, the joys of new construction. But anyways, so this I started out doing, and it actually worked fairly well. Once again, I'm not a physicist, so the physics part was really kind of rough, and I'm never happy about the physics part of this. And I know I used a level, but boy, this thing looks unlevel. Anyways, comments about the camera aside. We'll see if this survives in post. So I'm not a physicist, so I'm much less confident about physics. But it's like, okay, I'm going to start with atoms. I'm going to work my way up. At least this way I can start out with chemistry. I can do physics in the middle. I actually know more about astronomy. Once again, I have an astronomy minor for some reason. I like Star Trek, that's why. It was 1 extra class on top of P-Chem. P-Chem was not part of it. Sorry. Holding the recorder and it always likes to fall off. Okay, yeah, this is a more casual video if you hadn't noticed. So this semester I said, you know what, I need to double down with hands-on demos. And because one, that's a good way to teach a lot of science, is, actually do some stuff. And I want to figure out, one of the classes let me back up. When I was applying for this job back in 2014, 2015, I applied at a southern Indiana school. I will leave them nameless. Probably shouldn't have even said what part of the world they're in. That had issues. It was one of those where had they offered me the job, the answer was, no. They didn't, by the way. But one of the things I really liked about that is they had a class, basically this one, where they had a whole bunch of experiments. It was a lab-based course, and they were all designed so that the teachers or the teachers in training, once they became a teacher, could just take them, flip them over, and use them. No fancy chemicals, everything you could buy at the hardware store or Walmart or whatnot. I'm like, that's a good idea. I asked them for it, but they never replied to my email. Oh well. So I'm like, okay, I'm going to have to do this from scratch. And then one of my colleagues was actually kind of doing something on the same lines with their online version of this course. We teach a couple sections of this. Okay, so I started working on that one. And this actually worked pretty good. Now, this did mean I had to be in a lab. So I was in the brand new lab. We had the new lab. This was the first semester. It was really in use. I had actually used it slightly in the spring. Basically said, okay, folks, let's do some cool demos. I can't do them in this random classroom, but we'll meet in this other lab. Half the class showed up, half didn't. And we did some cool demos. And they're like, I wish we had been doing this all year. I'm like, okay, fair enough. So, we did. Now, this was one of those evening courses. It's one of those 4 o'clock classes. Like, if you're going to do a night class, do a night class. If you're not going to do a night class, don't do a night class. Don't cover dinner. And it's a 3-hour, once-a-week course. So it's one of those like, oh boy. The demos worked well. They were quick, though. They did not take nearly all 3 hours. So my plan for the class was do the demos for the first hour, have the students do hands-on. This is going to be hands-on demos. I came up with a decent amount. Astronomy, I have no idea how you do hands-on demos with astronomy unless you grab a telescope. And I don't know what I'm doing with the telescope. The astronomy minor didn't actually cover telescopes. It was like an astrophysics class, was basically the minor. But the chemistry demos, they all seemed to work well. The physics ones, for the most part, worked well. Once again, I'm not a physicist, so this was a struggle. But I've got a list of activities I need to add to it. Thankfully, our Science Ed Center had a couple of really nice resources like these Electric Connect kits that apparently all my students had used before. It was like, here's these really cool things. Oh yeah, these have existed for 20 years. We've all used them. Like, what? I've never heard of these things. But they were kind of cool. So I did that. And then the students, I have, on the other channel, I have all of my teaching videos. And it's like, well, you've got all these videos for the online course that are here for backup. How about we do hybrid? And this is the students. This is not me. This is the student realizing that they did not want to stay till 7 o'clock, and I don't blame them one iota. And they're like, instead of you lecturing for 2 hours, which was the plan, it was going to be do hands-on for like an hour and then me lecture for 2 hours. I did that like the first class, and the second class, like, hey, we got another idea. And there basically was, let's flip this thing. Let's do a flip class. We'll watch the videos beforehand, and we'll come and we'll ask you questions. Because what I end up doing, so all my classes, I give basically a list of learning objectives. They're reformatted in the form of a question. So it's not like students will learn how to calculate molecular weight. It would be, how do you calculate molecular weight? Or what are the 3 major components of an atom? Instead of students will know the location of protons, neutrons, and electrons, or something like that. So yeah, it's just a slightly different flavor. I think it works a little bit better if you're giving the students these guys, because they can't just think like, oh, here's something to look at. Ignore. It's like, oh, here are the questions. If I can answer these, I get an A on the test, which is valid. Yeah, if you can ask them really good, you're going to get an A on everything, because that's the learning objectives for the class. Duh. And so they're like, okay, we got the learning objectives. We've got your pre-recorded videos. We've got the book, which was absolutely worthless. I'm not requiring it again. And we'll just ask questions. Okay. And it worked out great. I mean, I felt bad most weeks. We were leaving at like 5:45 for a 4 to 7 class. It's going really, really short. But it was working. The students did reasonably well reasonably well. It was clear that they were not really in a good position after 5:30, 6 o'clock to keep learning. Because once again, this is a 4 to 7 class, and most of them had gotten up early to, do other things. And so it seemed to work. So I like that. I'm not going to impose that, but if the students say, hey, we want to flip this thing, yeah, fine, let's flip this sucker. And then I also built some POGIL activities, or guided inquiry learning, not technically POGIL because it's not affiliated with them. Joys of trademarks. And so we did several of those, and so that worked well. One of the feedbacks, so I do read the feedback. Most of the time, it's like, yeah. That class only got 2 pieces of feedback. I can't remember what the one was. The other one I think was slightly more okay. There's some communications issue, but it's valid feedback. It's like, well, I learned a bunch, but I didn't learn how to teach this. It's like, okay, this isn't actually a teaching course. I could see why you might think it is. It's not. It's this weird hybrid course. And it's actually here's all the science you're going to be teaching. You need to know enough of it to be able to teach it kind of course. So it's one of those, this is what you should have learned in high school. You may or may not have. We're making sure you know everything kind of course. But, okay, that would be an extra value add. I get it. This summer, I had done the workshop over in Purdue, or workshops, it was a conference. And one of the things covered was argument-driven inquiry slash SWH slash the hybrid between the two. This is the one, if you watch the video, I basically went to the wrong session. I went to like the history of argument-driven inquiry instead of the how to do argument-driven inquiry, which I am so frustrated about doing. The worst part of it is like I could have easily gone to the other one. I went to some other session I didn't really care about and didn't realize the 2 sessions were different. Anyways, enough venting. The core of SWH and argument-driven inquiry, both are pretty actually hardcore. They're basically the same thing, just the orders are switched around a little bit, which is why the hybrid works. It's another way of switching the order of different ideas. Both of those are pretty intense. They're basically pre-lab, post-lab. You're going to do a couple of days on a lab. If I teach the majors lab again, I think it would be a great thing to do with them. Honestly, it's probably a great thing to do with any lab, but it's pretty intensive. So if I've got the liberty to be intensive with the lab, I'll probably jump in on. But the core of all of these is called claim evidence reasoning. And this is a way of structuring an argument. You lay out a claim, and you lay out evidence, and then you use reasoning to get from the evidence to the claim. Think like court case almost. At least it reminds me of Perry Mason. That's as much as I know about court cases, but you know. And so I'm thinking about, I'm going to introduce that in the spring. I think that would be a great idea. I tried it in a couple of labs for my survey course, and it seemed to work okay. It was actually very clear that a lot of students in that particular course were struggling with the whole critical thinking thing. So it says, I need to do this more because this is an area where they're struggling with, because, yeah, they were not connecting the dots very well. Also, they were struggling with reading the question because they would answer half the question and not the other half. It's like, ew, this is cringe. So I need to work on that somehow too. But anyways, I want to add in the CER into the physical science course because this would, one, take slightly longer because once again, things were a little too short. I do think I needed to lengthen that out and do some more value add here. Second, I think it does help go through the logic. They were doing the demos, they were thinking about them, they weren't doing anything else about it. So if they engage more with the demo, hopefully they will learn more. And finally, this is a way to teach. This is a reasonably decent approach. It's kind of growing in K-12, so if they get some experience doing it as the student, hopefully this might be something value to them. So my goal for this class in the spring, chuck CER at everything. The only problem is it's a ton of grading. Because you assign it, you got to grade it. And these are basically little lab reports for all of them. There's some things I can do around this. I might crack out the whiteboards, because one of the tricks is you do this, but then you have the students share with each other. I don't know. I had mixed luck with the whiteboards in the previous class, but I think I need a lot more structure. So this is something I'm still just barely beginning to learn how to do. This is also going to take a lot of work, so I don't want to overload myself too much, because once again, I'm already on overload. The book I've been using is horrible. There are 2 books. Both of them are lousy. Both of them are overpriced. Both of them come with online homework systems. However, the one I'm currently using is Pearson because that's what everyone else is using, and I have literally never gotten Mastering Physics, because of course it's Mastering Physics, not Mastering Chemistry. I have never gotten Mastering Physics to actually work. I should correct that. I can use my personal email account, but I can't use my school email account. And I am not giving my students my personal email account, because of course not. Also, just like there's so many things wrong with trying to do it that way. So I'm not using Mastering Physics because I literally can't. Yeah, and tech support is like less than helpful. It's like, well, that's not our problem. You can't use it. Anyways, don't get me going on Pearson. Gone too long. There's also one by, I think, McGraw-Hill. I can't remember who does the other one. They've got an online homework system I like better, but that's a different book than what the life science version of this course is using. So this way, if they got the one, they don't have to buy it twice. It's still a dreadful book. They're both kind of like, ugh, this is mediocre. So what I'm going to be doing, and my goal is, hopefully, I hope I can get this done. There's going to be a lot of work, is go through LibreText. If you've never used LibreText, check them out. They are awesome. I'm going to go through LibreText, and the goal here is to then just start picking and choosing from LibreText and use the learning management system to do kind of a custom textbook. And the computer screen went black again. I like to put the earth as a background. Yeah, that's a screensaver I picked up 20 years ago. Sadly, maybe slightly more. I'm getting old. I just love that screensaver. But anyways, where was I? Oh yeah, so my goal is to use LibreText and basically kind of build a custom textbook via links in the LMS because it's good and it's free. Trust me, if you have not checked out LibreText, do so. They are really good. And if you're already using a textbook, they've got lots of like, I can't remember what they're calling, they're like mapped to, or basically they've structured their content in an order that resembles other textbooks. So let's say you're using Brown and LeMay for your chemistry class. They've got their content that's in the same order as Brown and LeMay. Or you're used to using Brown and LeMay, but you want to ditch it and you want to go LibreText. So it's all the content's still in the same order. With open source licensing for all their pictures. So obviously they can't just copy the pictures over. That would be illegal. Okay, so that's the Foundations of Physical Science course. Organic 1 and 2 labs, those were the first time I've taught those in years. Those were a little bit rough. I had a couple of, the labs were like, I don't quite know what I'm doing with this one because I've never done this lab before. Thankfully, the lab assistant was a lab assistant for all the sections. And so I was like, hey, what'd the other guy do? Okay, yeah, sounds good. But I only had that for Organic 1 because that was the larger course. Organic 2 was off sequence and much, much smaller, so it was just me, which was fine except for the last lab. I didn't realize you had to make one of the reagents fresh, and our lab stockroom guy didn't know that either, so he pulled out last year's method, and it didn't work, surprisingly. It was a year old. Well, from spring. Still way too old. I got one comment from the student responses, which was like, oh, you made me feel good. Which was basically like they really liked the, let's figure this out attitude, which is kind of, actually for a high level lab, that's usually my attitude with those labs. It's like, I don't know why it didn't work. Let's figure it out. Do it again. It's like, it's chemistry. It's called research for a reason. You're going to redo it. Also, I noticed the scores for the numeric part of my student evaluations were pretty much tracked with the class level of the students. So the first years gave me fairly poor scores, and all the upper class students, especially the juniors, gave me actually really nice scores, relatively high ones. I was like, huh, okay. Okay, on to survey. So changes here. I used a little bit of the CER that I mentioned earlier. It's a lot of work grading, but I think it's worth it. I'm going to keep doing that. I'm probably going to tag that onto most labs. I am definitely finding they do need some time to work on it, and frankly, I want them to type this so I don't have to read their handwriting. Yeah, we need to work on this one a bit because one of the soft skills that we get told about by industry quite a bit is critical thinking, that we really need to work on critical thinking, and yeah, it's pretty obvious we do. And so I really want to kind of drill down on that one, kind of make that part of the thing for my larger first year classes, either the general chemistry or the GOB Chem. Did specs grading, again, liked it. I think it worked well. Once again, you would think if you had 3 tries to do a problem that's going to be basically the same problem, and you've worked that basically the same problem on the board, you would get it right, like all the time, and not quite. Yeah, the average for the specs grading parts was probably in the 70-some%, right about where you would expect a test to be. So it's like, okay. This means we are really separating those students who know the content from the students who don't. And as such, like, you know what? This is a valid approach. It's definitely easier to grade, more transparent. Yeah, I'm going specs grading all the way. I mean, not all the way, but I'm looking at my, rubrics, and instead of doing like 20%, or not rubrics, syllabi. So instead of doing 20% specs grading in the spring, I'm probably going to do 40 or something like that. So I'm going to keep maybe the tests in there. Basically, I have to have a few days aside to do retakes of the specs grading because I'm not doing this outside of class. And so I might as well do like a little vocab test or something. Maybe, I'm not for sure. I'm still working out exactly how I'm going to do this in the spring, but I'm definitely doubling down on the specs grading. I think it worked out well. I do know several students didn't like it. Several of the comments were they did not like the specs grading. And once again, like, guys, I worked the problem on the board. You worked on the specs grading. You worked on specs grading version 2. You worked on specs grading version 3. They're the same dumb problem, just with different numbers. You had 3 tries. You really should have been able to get this done. This is not an unreasonable ask, and I think it really does separate out A's, B's, and C's kind of thing. So, yeah, even though I think several students didn't particularly like it, I think they didn't particularly like it because they didn't step up to it. Not knowing who did what, it's anonymous reviews, kind of a hard thing to deal with. Or trying to track and figure out why they're making certain parts if I don't know who they are. But, obviously they're anonymous for a reason. Let's see, that's kind of the major takeaways from the survey course. Lots and lots of exercise science majors. This was very unusual. Normally that class is full of nursing majors. Because nursing majors, at my school, you can take either a survey of chemistry or there's a biology course that you could take instead. Most schools, you take the chemistry class. It's 1 or 2 different versions of a GOB course. You have to take that. So for our students, if they don't take me and they wish to transfer, they're going to have to take chemistry anyways. Either with me or with somebody else, at their new school. A lot of the nursing program really decided not to take my class. I don't know if this is the advisor, if it's word got out that, hey, I'm much harder than the biology course. I have no idea. But I was flooded with exercise science students. I had enrollments higher than I'd had in years. It was almost entirely exercise science. A small clump of just people needing random, science credits. But yeah, that also means, though, because the exercise science only take the first half, they don't take the second half with me. They have their own version of the second half. We have like 4 different biochem courses in this school. It's very weird. We got the full biochem course for chemistry majors. We got the short biochem course for biology majors who all want to take the full biochem course. I don't know. I don't understand what's going on there. I don't make up the courses. I've got my second section of GOB, which is basically organic or biochem with a side of organic, and then there's an exercise science biochem. And there might very well be a 4th or 5th biochem. Actually, I think there is. So it's like, yikes, we got tons of different biochem courses. Maybe we need to consolidate. But my spring GOB course, I've got like 10, 12 students in there, so it's going to be weird. That's not, it's normally smaller, but that's like real small because, once again, no nursing majors. So I'm teaching a general chemistry course because we're short staffed. We cut a section of that out in the fall. So I'm literally packed. The room holds 64, or has 64 chairs, and I've got 64 plus like a 10-person wait list last I checked, which has been a while, so hopefully it's shuffled around a little bit. So yikes. And so I'm going to kind of take what I learned from the survey and move that into the principles as well. Yeah, so it's kind of year in review. We're going to want to check out that LibreText, actually get through and doing that one, but it takes a lot of fishing. So I don't know if that's going to get done. I really want to get that done though. Definitely doing CER. I'm afraid I'm going to shoot myself in the foot with extra grading, but I'm hoping to relieve some grading by really doubling down on the specs grading, because it really has worked in spring and fall of 2022. Both semesters I had a lot of good luck with it. I definitely learned in spring I needed to do 3 tries, not 2. 2 was a lot more convenient, but I do need to do 3 tries. I don't think a 4th is going to help them, to be honest. After a 3rd try, especially what I learned in Purdue, I don't think the 4th is going to help. And then, yeah, that's kind of looking forwards. And just a semester on job search committee, because once again, staffing issues. Finally, admin let us search for the 2 or 3 jobs we're missing. We're down 3 people. They're letting us search for 2. They basically said, forget it. You're never getting a 3rd person back. I'm like, but otherwise, yeah, that's the year, at least for me. Hope your year has gone well. And with that said, have a wonderful day, and I will see you in 2023.